Vectors and coordinate system. Suppose we have the following objects, which we know represent the same vector. But they are not really useful unless we have a proper way to name them, to be able to work with them. We use coordinate system, and it works in the following way. All of these vectors are the same as the vector starting from the origin of the coordinate system, and we say, this vector is the vector 1, 2, where 1 is the x-coordinate, and 2 is the y-coordinate. For simplicity, I am just considering vectors in 2D only, so we have 0 in the z-axis here. But if we consider in 3D, then we'll have z-axis as well, so 3 values describing the vector, and so all the vectors can be described by bringing them to the origin and naming them based on the x, y, z coordinates of its endpoint. Let us now look what happens when we sum two vectors. We still keep the analysis in 2D for simplicity, and the exact same thing works for 3D too. So, suppose we have the following two vectors, 1, 2, and -2, 1. We want to find their sum. We use the definition of the sum of vectors, so map the starting point of the second vector to the endpoint of the first vector, to get the sum of the two vectors equal to the following vector. It turns out, the new vector is now the vector, -1, 3. This is because we moved 2 units to the left and 1 unit up from the first vector, and then went 1 unit to the right, and 2 units up from the second vector. So, we sum -2 to 1 to get -1, and we sum 1 to 2 to get 3. So, the x-axis of the new vector is the sum of the x values of the two vectors, and, similarly, the y value of the new vector is the sum of the y values of the two vectors. We conclude that for summing up two vectors we just sum up the x and y components. Now suppose we have a new vector here, and we want to find the same vector with a negative sign. We know this is a vector with the same length and reverse direction, so the following vector. The original vector was the vector -1, 2, and the one with negative sign is apparently the vector 1, -2. So, if we are careful we can see that just the signs of the x and y components have changed. And so, minus the vector -1, 2 is the vector 1, -2. This means, for subtracting one vector from another, we just subtract their components. Finally, let us look what happens when we multiply a vector by a constant. Suppose we have the following vector, -2, -1. Then, 1 over 2 times this vector, as we know, is simply the vector with the same direction, but half of the distance, so the following vector. This vector now has x-coordinate equal to -1, and y-coordinate equal to -0.5. So the new vector is now the vector, -1, -0.5. It turns out, when we multiply a vector by a constant, we simply multiply all the components by the constant, as in this case. Finally, recall that we were considering all these properties for 2D only, but in 3D, the same properties hold exactly the same way, so ABC plus DEF is equal to A plus D, B plus E, C plus F. When we have subtraction, ABC minus DEF, we can consider this as ABC plus minus DEF, so we get A minus D, B minus E, C minus F. And the last property is that any constant k times the vector ABC is equal to k times A, k times B, k times C.